Okay, the next few questions are worded just a little bit differently, but they're very similar. So this is showing me how many atoms are in 28.09 grams of silicon. So the first thing you're going to do is think about that it's asking you how many, okay, keyword how many, it's counting, and it's giving you a mass. So we want to check that that mass represents the mass, the atomic mass of silicon, and if so, then we know our answer. It's always going to be 6.02 times 10 to the 23, as long as those numbers match up. Same for the next question. It says how many. It's giving me a mass for a certain element, so I need to check my periodic table. If those numbers are the same, then we know our answer, because 1 mole of an element always equals 6.02 times 10 to the 23 atoms, and it will weigh the atomic mass that's shown on the periodic table. So that's why we need our periodic table, and we're always going to be checking. Okay, what if you have it worded another way? What if in this question it's saying what is the mass of 1 mole? Notice the question is slightly different. It's not asking me how many, it's asking me the mass. Okay, but I do know that 1 mole is always represented on the periodic table as the atomic mass. So I look up nitrogen, I look up the atomic mass number, and that gives me my answer of how much 1 mole would weigh. But look at how your unit now is in grams, because it was asking me the weight. Next question says I have 6.02 times 10 to the 23 atoms. That represents 1 mole, and it's asking me how much does it weigh. When it asks me how much does it weigh, I check my periodic table and I look at the atomic mass, and that's my answer. Next question, same idea. Look, it's giving you 6.02 times 10 to the 23 atoms, which I know represents 1 mole of something. So I'm going to check the periodic table to see how much it weighs. Always look at the atomic mass, not the atomic number, because that's going to tell me how many grams. So my answer is 22.99 grams for 1 mole of sodium. So what if you have something that's not an atom, but rather it is a, molecule, or it is a compound. It's not just 1 atom. So in that case, we're still going to be looking at our periodic table, but we've got to do a little bit of math. We're going to be looking at the atomic mass for each element in the compound, but then we have to check the subscripts to see how many atoms of that element are in the compound, and then we're going to be adding up the totals. So here's an example showing what we would do. We would have to look at our periodic table to find that the mass of carbon is 12.01, but my subscript tells me that there are 6 of those atoms. So we're multiplying, and we would get this for carbon. You would do the next calculation for hydrogen. Check the periodic table for the mass, look at your subscript for how many atoms, and multiply those. For oxygen, check the periodic table for the mass, look at your subscript for how many, multiply them, and then you add all of those answers up to give you your final total, which is represented with the unit grams per mole. That's G/mol right there. Okay, let's practice. So let's say you are asked for the molar mass of Cl2, which is chlorine gas. So first thing you are going to do is check your periodic table, and you're going to figure out the atomic mass of 1 chlorine atom. So 1 chlorine atom, according to my periodic table, is 35.45 grams. But I'm going to multiply that by 2 because I have 2 in my formula. And just use your calculator to get your answer. 70.9. And make sure that you put your units grams per mole, because 70.9 grams in 1 mole of that substance. Okay, here's the next one. It says the molar mass of oxygen gas. Well, you have to ask yourself if that's a diatomic element, and it is. So we would know that the formula for oxygen gas is O2. And that's going to help me when I figure out my calculation. I'm going to look on my periodic table and find that the mass of oxygen is 16 grams. And then I times that by 2. And that's going to give me 32 grams per mole. Okay, this next example, we've got ammonium sulfide, and our formula is more complicated, so a little bit more math. So you're going to want to take each element one at a time. Let's start with nitrogen. And for nitrogen, I look on my periodic table, and it's 14.01 for the mass. But then how many do I have? Look outside the parentheses at my subscript 2, and that does distribute inside, so it's going to be 2 nitrogens. All right, so that's my nitrogen. Then let's set up the next element. Next, let's look at the hydrogen. So on my periodic table, the mass is 1.01, but how many do I have? Well, I've got 4 inside the parentheses, but the 2 on the outside, so we have to multiply those, and there would actually be 8 hydrogens. Next, we're looking at our sulfur, and there's only 1, so we just write down the mass from the periodic table, and that's how you would show your work. So now you can get your calculator, make sure you pay attention to multiplying what's inside the parentheses first, do your order of operations, and if you do that correctly, you're going to get this answer, 68.17 grams per mole. Let's do one last example, aluminum nitrate. Now this time you have to write the formula first, and we need to be really careful to do it correctly, otherwise our math will come out incorrectly. So we'd have to think about our charges. So for aluminum, we know it's a 3+ charge. Nitrate is an NO3 with a minus. Therefore, my formula is going to have 1 aluminum, but 3 nitrates to make those cancel out. Okay, this is the formula we do our math with. So you're going to look on your periodic table. Let's start with the aluminum. That has a mass of 26.98, and there's only 1. So next, let's think about our nitrogens. Don't forget to distribute the 3 inside. So we take our mass of the nitrogen, but we have to times by 3. Next, for our oxygens, again, don't forget to distribute the subscript on the outside and multiply it by the one on the inside. So I take my mass of oxygen, which is 16 from the periodic table, and we're multiplying that by 9. Okay, get your calculator. Go ahead and calculate that out. And if you did that correctly, you should get this answer, 213.01 grams. Notice that we're always rounding to 2 decimals. Let's just all do that to be consistent. Okay, so those are your examples, and then I'm going to give you a homework page where you can practice, and I'll post some more videos with some more practice. Hope that was helpful, and take care, scholars. I'll talk to you later.